Inside the shadow of Geneva under the world's surface lies a wonder of human resourcefulness and potential harbinger of annihilation, the enormous Large Hadron Collider, LHC. This machine is an uncommon device for researchers, empowering them to study subatomic particles and uncover the secret of the God particle, the Higgs boson. Famous physicist Brian Cox has made a chilling declaration that has sparked a whirlwind throughout the religious community, proposing that something significant has been discovered at CERN with implications beyond our current understanding. Before delving into the ramifications of Cox's assertion, it is fundamental to understand how the Large Hadron Collider works. Operated by CERN, the LHC is a 17-kilometer ring of superconducting magnets and the world's most powerful particle accelerator. It stands as a zenith of human accomplishment, capable of reproducing the conditions of the universe's creation. This titanic design allows us to unlock the secrets of the universe, uncovering something real and potentially disturbing. CERN, established in 1954, is one of the world's most famous research institutions, containing 23 member states and an immense range of specialists. The LHC is CERN's focal project but is only one piece of a broad network of accelerators and detectors that explore the subatomic world. The LHC accelerates protons to almost the speed of light, recreating the energy of the universe at the time of the Big Bang. The subsequent impacts generate temperatures millions of times hotter than the Sun's core, with a complex arrangement of magnets directing the protons on their journey, while advanced cooling systems maintain the magnets at temperatures colder than space. The LHC's design is an engineering marvel, working deep underground, protected from cosmic radiation. The entire ring is cooled to a temperature colder than the vacuum of space, which is crucial for the superconducting magnets to function. Collisions occur at 4 points along the accelerator ring, each corresponding to one of the 4 main particle detectors: ATLAS, CMS, ALICE, and LHCb. These detectors capture the aftermath of collisions, allowing researchers to sift through the debris in search of the elusive Higgs boson, a particle key to our understanding of the universe's structure. The LHC is not only a scientific instrument but a testament to human creativity and aspiration. It represents our quest for knowledge and our desire to understand the fundamental forces shaping our universe. However, as we push the boundaries of our understanding, we must also consider the moral and existential questions that arise. What are the dangers of exploring the unknown? Could our quest for dominion unintentionally unleash forces beyond our control? Within the hallowed halls of CERN, where the frontiers of human knowledge are continually expanded, a revelation has emerged that has sent shivers down the spines of even the most seasoned scientists. Brian Cox, a former researcher at CERN and a respected voice in particle physics, recently made a statement that has both amazed and frightened the scientific community. The goal of CERN's Large Hadron Collider is to recreate a miniature version of the Big Bang, the event that birthed our universe. Cox also highlighted the potential outcomes of this goal, noting the LHC's remarkable ability to create new phenomena, including its potential to reveal the Higgs boson and study dark matter, a substance that constitutes a significant portion of the universe. The possibility of recreating a mini Big Bang is not just a theoretical concept, it is a tangible reality within the LHC. The conditions inside the collider mimic those that existed at the universe's inception, allowing scientists to observe the birth of existence itself. However, with such power comes great responsibility and potential risk. Consider the scenario where something goes disastrously wrong. In 1978, Russian physicist Anatoly Bugorsky experienced an accident at the Institute for High Energy Physics in Russia, where a malfunction caused his head to intersect with a proton beam, resulting in severe injuries. Despite this, Bugorsky survived and continued his work, highlighting the immense power and potential risks of particle accelerators. The dangers associated with a particle accelerator like the LHC are not to be trifled with. The potential for unforeseen reactions and the manipulation of the very fabric of reality are genuine concerns voiced by some in the scientific community. One of the most significant fears surrounding the LHC's experiments is the possibility of creating miniature black holes, regions of spacetime with such strong gravitational pull that not even light can escape. If the LHC were to produce such an entity, even on a small scale, it might potentially consume the Earth from within. However, Scientists at CERN have assured the public that any black holes created would evaporate almost immediately. Understanding how the LHC could produce a black hole involves the fundamental mechanics of particle accelerators. When protons are smashed together at near-light speeds, the energy is so intense that it could warp the fabric of spacetime itself. Imagine a trampoline stretched tight with a heavy weight dropped onto it. The surface would warp, and if the weight were sufficient, it could create a hole. This analogy illustrates the LHC's potential to create a gravitational anomaly, an intriguing yet alarming possibility that has even caught the attention of prominent physicists like the late Stephen Hawking. In his writings, Hawking warned that the Higgs boson might become unstable at extremely high energy levels, potentially causing a catastrophic vacuum decay, a vast event that could destroy the universe. Respected cosmologist Sir Martin Rees has also expressed concerns about particle accelerator experiments, including those at CERN. In his book Our Final Century, he revisits the potential risks of particle collider experiments, including the formation of vacuum instability. This instability could hypothetically trigger a phase transition that would ripple through spacetime, causing a catastrophe of unimaginable proportions. While these scenarios remain highly speculative, even a slight possibility warrants serious consideration. The stakes are incredibly high, and the margin for error is razor-thin. The experts at CERN have meticulously assessed the potential risks associated with their experiments and implemented numerous safety protocols and safeguards to mitigate any potential dangers. However, scientific exploration inherently involves a level of uncertainty, especially when venturing into uncharted territories. The pursuit of knowledge has always been accompanied by risks, but it is precisely this willingness to push boundaries that has driven human progress. The LHC represents the culmination of decades of scientific advancement and international collaboration. The LHC enables scientists to recreate conditions just moments after the Big Bang, providing a unique opportunity to study the Higgs boson and other fundamental particles. The Higgs boson, often referred to as the God particle, was hypothesized in 1964 by Peter Higgs and others as a crucial component of the Standard Model of particle physics. This model describes the fundamental forces and particles that constitute the universe. The discovery of the Higgs boson at the LHC in 2012 confirmed the existence of the Higgs field, an invisible field that gives mass to other particles. This discovery was a monumental achievement, validating decades of theoretical work and enhancing our understanding of the universe's underlying structure. However, as with all significant scientific endeavors, the pursuit of knowledge at the LHC is not without its potential dangers and ethical dilemmas. The energies involved in particle collisions at the LHC are immense, and the possibility of creating new forms of matter or triggering unforeseen reactions cannot be entirely dismissed. Some researchers have speculated about scenarios in which high-energy collisions could produce miniature black holes or other exotic substances, raising concerns about the potential consequences of such events. While most scientists consider these risks to be extremely remote, the very nature of scientific inquiry involves venturing into the unknown. Brian Cox's assertion highlighting the possibility of recreating a mini Big Bang within the LHC underscores the profound significance and potential dangers of this research. The Large Hadron Collider represents the cutting edge of human scientific achievement, enabling researchers to explore the deepest mysteries of the universe. Yet, as we delve further into the fabric of reality, we must also confront the ethical implications and potential risks associated with such groundbreaking discoveries. The questions raised by the LHC's experiments are not merely scientific but also existential, prompting us to consider the limits of human knowledge and the responsibilities that come with wielding such immense power. Ultimately, the Large Hadron Collider serves as a testament to humanity's unquenchable thirst for knowledge and our willingness to confront the unknown in our quest for understanding. But as we push the boundaries of our understanding, we must also remain vigilant and mindful of the potential dangers that may arise from our pursuit of the mysteries that lie at the heart of the universe. Yet beneath its impressive exterior lies a domain of profound scientific inquiry, filled with potential dangers and ethical considerations. The collider's primary goal of unraveling the mystery of particle physics has led to remarkable discoveries, including the elusive Higgs boson. However, The immense energies generated within its confines also raise concerns about the potentially disastrous consequences of such an endeavor. While extensive safety measures are in place to mitigate risks, the possibility of catastrophic events such as the creation of microscopic black holes or other unforeseen anomalies cannot be entirely ruled out. As researchers continue to push the boundaries of our understanding, it is crucial to approach these investigations with a keen awareness of potential outcomes and a commitment to transparency and public discourse. The LHC, with its unparalleled capabilities and potential for groundbreaking discoveries, stands as a testament to human ingenuity and a relentless pursuit of understanding the fundamental laws of the universe. However, beneath its awe-inspiring exterior lies a realm of significant scientific inquiry, replete with potential risks and ethical considerations. The Collider experiments tap into energies and forces that are beyond the comprehension of most people. The collision of subatomic particles at near light speeds creates conditions akin to those that existed in the universe's earliest moments, allowing researchers to probe the fundamental building blocks of matter and explore the very fabric of spacetime. Yet the immense energies involved in these collisions also present critical risks, both known and unknown. One of the most pressing concerns surrounding the operation of the Large Hadron Collider is the potential creation of miniature black holes or other exotic phenomena that could have unforeseen consequences. While theoretical models suggest that any such black holes would be ephemeral and pose no threat to Earth or its inhabitants, the prospect of inadvertently unleashing forces beyond our control remains unsettling. Additionally, the sheer scale and complexity of the experiments conducted at the Collider necessitate rigorous safety protocols and oversight to minimize potential risks. The global community of scientists and researchers involved in the Collider operation is acutely aware of the need to prioritize safety and ensure that all experiments are conducted with the utmost care and responsibility. The Large Hadron Collider, with its remarkable ability to probe the fabric of reality, is not only a marvel of modern engineering but also a focal point of contemporary physics and cosmology. Its primary objective, to investigate the fundamental particles that make up the universe, has significant implications for our understanding of existence.